Safdari-Vaighani. I'm from Tabriz University, Faculty of Computer Engineering, and it's a great honor to have you here. I will be presenting a paper entitled Detecting Non-Spherical Clusters Using Modified Kerr Algorithm. We will continue the presentation in following order. First, the abstract, in which we will talk about what we have done in a glance. Introduction, we will talk about methods that have been tested before. Next, methods used algorithm in this paper. The results, which shows outcome of proposed method. And finally, conclusion and references we will see in this presentation. Clustering using representatives or Kerr algorithm is a robust hierarchical clustering algorithm which is dealing with noise and outliers. Kerr algorithm merges and divides the clusters in some datasets which are not separated enough or have density differences between them. The obtained results show that Kerr clustering is sensitive to input parameters. In this paper, the advantages of density-based clusters, cluster center detection are represented, and the modified Kerr clustering algorithm is developed. The new algorithm determines the cluster centers and doesn't allow merging the clusters which contain cluster centers in data points. Experimental results show that the proposed algorithm has the capability to extract clusters more efficiently than the traditional Kerr algorithm. Clustering is an unsupervised method that classifies data objects into meaningful subclasses that's name is cluster. Data points in each cluster are possibly similar and dissimilar to data points in other clusters. Clustering algorithms could be roughly categorized into several main branches such as density-based, centroid-based, and hierarchical. Density-based clustering algorithms are dependent on the concept of finding the density of the specified area. DBSCAN is the most famous density-based clustering algorithm. DBSCAN has the ability to discover the number of clusters, identify the noise, and extract clusters of spherical and non-spherical shapes. Centroid-based clustering algorithms are dependent on the concept of cluster centers. K-means is a centroid-based and one of the most popular clustering algorithms. The results of K-means clustering highly depends on the selecting initial centers. Repeated K-means and improved K-means are developed forms of K-means algorithm. And Q, HCNN, and Q with SNN are examples of hierarchical algorithms. There are two types of hierarchical clustering algorithms, agglomerative and divisive. Agglomerative follows a bottom-up approach that builds up small clusters with single data points, and then by merging them until satisfying a certain termination condition completes clustering. Divisive follows a top-down approach which builds one cluster containing all data points and then divides the big cluster into smaller clusters until it satisfies certain termination conditions. Kerr algorithm is an agglomerative hierarchical clustering algorithm, so it follows a bottom-up approach. In the first steps of this algorithm, each data point is considered as a cluster which contains only one data point. Then, for each cluster, the closest cluster is calculated by using representative points of clusters. After that, two closest clusters are selected, which has the shortest distance, and bigger clusters are built by merging the selected ones. Q algorithm could handle noise outliers and extract arbitrary shaped clusters, but in some datasets, it merges main clusters and makes two big ones, or it divides the main clusters into smaller ones if they are not separated enough or have density differences between them. Also, this algorithm needs two parameters which it's so sensitive about, and in some cases setting the parameters is so difficult or impossible. Last but not least, it makes mistakes in extracting the closest clusters in high-dimensional datasets, because this algorithm uses some of the data points for representing clusters, and if the number of representatives is considered a small number, the algorithm will have trouble in finding closest clusters. And all of these reasons cause getting wrong results of cluster extraction in some datasets when we are using traditional Q algorithm. A relative density relationship is used in modified Q algorithm to obtain appropriate results. So in the first step of the modified Q algorithm, cluster centers are extracted by using density parameters. The second, third, and fourth steps are the same as the traditional clustering algorithm. In these steps, single-point clusters are created, the closest clusters are discovered, and the two closest clusters to each other are selected. Modified Q algorithm doesn't merge clusters if both of the clusters contain a cluster center data point, and this condition is checked in step 5. If the condition in step 5 is well checked and proved to be right, the two selected clusters will be merged in step 6. Until the number of clusters are reached to desired number, the step 3 to step 6 will be repeated. Experiments in this paper are performed with 5 datasets, and this paper shows the attributes of each dataset. SIDS, WDBC, IRIS, and BRIS are real datasets, and the Jane is a synthetic. This figure shows the accuracy of 3 algorithms such as dbScan, traditional Q, and modified Q for the mentioned datasets. As you can see, modified Q algorithm has a better performance in extracting appropriate clusters rather than 2 other tested algorithms. In 4 first datasets, which are real, the performance of a modified Q algorithm is remarkably better than other 2 algorithms, especially the traditional Q algorithm. But in the last dataset, the difference between performances is not noticeable. Here are some of outcome results for WDBC datasets. Figure 4 shows the actual distribution of data and the right form of clustering them. Figure 5 shows the way that modified Q algorithm clustered the data point, and it's more similar to original form of clustering than the figure 6 that shows the way the traditional Q algorithm clustered the dataset. The reason of its better performance is that it didn't merge the 2 main clusters unlike the traditional Q algorithm, and the 2 red points in figure 5 displays the cluster centers, which is not applied in traditional Q algorithm. This slide contains another set of datasets which has the exact pattern of performance for both modified Q and the traditional Q algorithm. The traditional Q clustering algorithm has some difficulties in setting hyperparameters for having the high efficiency. In this paper, we proposed a modified Q algorithm that uses density-based cluster center selection for obtaining the cluster centers. Detecting of cluster centers makes Q more robust against outliers and noise, and helps to reduce the sensitivity of traditional Q input parameters. We found out in some datasets Q cannot extract optimum clusters and merge some of the clusters or divide the cluster into two clusters, while truly chosen cluster centers prevent Q merge separate clusters. There are numerous methods for clustering, but in my opinion, the things that can be done in the future is to improve the algorithm by improving cluster center selection method, or using density of data points to select clusters to be merged in order to decrease the sensitivity of input parameters in Q algorithm and obtain better results. Here there are the references and related works that have been done before and we used in this paper. And finally, thank you for your time and attention, and I hope you enjoyed my presentation.